and would like to welcome you to the Next Horizon, the event model. Today's webinar is brought to you by Knowledge Partners International, the thought leader in the fields of business process management, decision modeling, and requirements. I'm Jeremy Baggish, and I'll be your moderator today. I have a few short announcements, after which I'll introduce you to our presenter, and away we'll go. First, some housekeeping notes. In order to assure best audio quality, listeners will be muted during the presentation. But you can participate in the Q&A session by submitting questions at any time during the webinar. Just type your question into the Q&A section of your GoToWebinar control panel. This event will be recorded. We'll post the link to the recording of this webinar when it becomes available. Today's webinar is part of KPI's Innovation Series. We also welcome you and your colleagues to join us for a free webinar on the second Thursday of each month as part of our 2014 Education Series. The next webinar in that series comes up this Thursday, which is Sapiens Decision powered by the Decision Model, Enterprise Scale Decision Management. Our IIBA-endorsed Decision Modeling Essentials online class is available on a monthly basis. Beginning every third Tuesday, Decision Modeling Essentials Online is a 3-day class meeting for 3 hours each day. Please visit the events section of our website to learn more and to register. But hurry, May's course is already sold out and June's is filling up rapidly. For qualifying companies, we're offering private web-based lunch and learn events and on-site days of discovery. Please contact us in case you'd like to take advantage of these offerings. It's now my pleasure to introduce today's presenter. Barbara Von Halle is Managing Partner and Founder of Knowledge Partners International, KPI. She is co-inventor of the Decision Model and the Event Model and co-author of the book The Decision Model, a business logic framework linking business and technology, published by Taylor and Francis in 2009. She is the 5th recipient of the Outstanding Individual Achievement Award from Data Management International, the premier organization for data professionals worldwide, which inducted Barbara into its Hall of Fame in 1995. She is an early pioneer in data architecture and business rules. Her first book, Handbook of Relational Database Design, has sold over 21,000 copies. Barbara was the most popular contributor to the Database Programming and Design magazine for years and co-authors regular decision model columns in tdan.com and modernanalyst.com. In addition, she serves as QA consultant on decision modeling and requirements projects and, in collaboration with KPI and its clients, continues to impact the development of the decision model and the event model. Ladies and gentlemen, it is my pleasure to present Barbara Von Halle. Barbara, they're all yours.
Okay, thank you, Jeremy. I am really excited to see how many people are interested in the event model. In all honesty, attendance today has exceeded our expectations, so this is a very exciting time for the event model. Based on your answers to our questions when you registered, I know a little bit about you. Many of you are familiar with the decision model, and for you the similarities will be well understood when you see the event model. However, there are some of you who are not familiar with the decision model, but for you the webinar will still be useful because it is our goal that at its core the event model should be relatively easy to understand. So while the usage of the decision model has been growing since 2009, the event model was under construction starting in IBM with Ofer Etienne and his team, who I will introduce on a timeline in a few pages. But recently, we at KPI were invited to join the team of IBM researchers to improve the current day event processing paradigm and approaches with a model somewhat similar to the decision model. And so that was a goal that we tried to do together. This presentation introduces part of the results of that joint study agreement. And you'll notice that some of the pages contain both a KPI copyright and an IBM copyright, and those pages are some of the deliverables directly from that research joint study. So let me begin by saying, before I kick off the agenda, that the event model is a new model. It has similarities to and important differences from the decision model. The event model today, in 2014, I believe, is in its early stage, just as the decision model was in around 2008, when we first began to test it with clients. So keep in mind that we did the testing of the decision model without any commercial supporting software at that time. So the event model, like the decision model back then, is defined ahead of specific commercially available supporting software. It seems to me that there's a lot of interest in the event model. I've had 2 opportunities to present it before this. And one of the reasons I think is that the general understanding of events even in everyday life, is perhaps more widely intuitive to people than the formal understanding of business logic and business decisions was and business rules were in 2008. So let me move to our agenda for today. I have, or objectives for today. The first one may seem unimportant. It is to revisit lessons from past history about similar models. But to me, in fact, this is quite important because revisiting past successes can crystallize a potential future. So my hope is that this presentation opens your eyes to an exciting vision and that you find it fascinating to be exposed to the edge of the research that is new and very promising. The second objective is where I'm going to spend most of my time. I will present the need for the whole new model called the event model, and I will show you some of its pieces and how they fit together nicely like a puzzle. So that was our goal, and to make it intuitive, easy to understand, and to fit together. And lastly, we will all be left with a burning question. Who will create these new models? Lastly, and because of that, we'll go back, or I'll mention to you now that when we came up with the decision model, we asked ourselves the same question. At first, we thought data modelers would do them because the relational model and decision model have some similarities. We thought maybe process modelers would do it because they had been the ones creating the logic inside process models or as little comments for many years. And perhaps requirements analysts or business people, because these were the people we designed the decision model to be for. Our answer today for the decision model is we find it is built by process modelers, business analysts, requirements, and business people, often working as a team. Sometimes data professionals join the team if they're looking at data quality logic. But who will become the creators of the event models? Well, we don't know for sure, but we'll take a guess at the end of the presentation. So this webinar then is divided into 3 topics. The first is called Innovating Past Dimensions because I want to point out the value of where all of us have come from. And in particular, the 2 models that change the way we do some of the things today, the relational model and the decision model. And this will be rather brief. But most importantly, I want to point out that these models have taught us certain things that we have now taken forward into the world of event modeling. So I'll start with a timeline. And for me, this is a powerful timeline. If you have lived during these years, you understand why I say that. But if you have not, just bear with me for a moment because I think you may learn some interesting things. It's a busy timeline, and I'm only going to point out 3 areas. The first part is that the relational model was revealed in a paper by Dr. Codd from IBM in 1969. It was a predefined abstract data model that was technology independent. But those were unfamiliar words back then. From this model emerged the relational systems as we know them today. But what you may not know is that these were the first systems ever to be constructed in accordance with the prescriptions of a predefined abstract model. That is, the relational model existed before there was the specific relational technology for it. Relational systems from IBM appeared in 1983, and it is interesting here that in 1989, Candy Fleming and I wrote the book Handbook of Relational Database Design. So it took us 20 years to understand Codd's model and the technology and how to marry that to a diagramming technique among many people who were working on that at that time. So that's the first one. And the second part to cover very briefly is that prior to 2009, the business rule space had no universal diagramming or full model theory. There were decision tree table theory, but there wasn't a full model theory. So Larry and I, after testing the decision model with our clients, we published a book that brought together the model theory behind the decision model and a diagramming technique for the management of business rules and logic. And it was sort of a repeat of what I had done with Candy Fleming in working with Dr. Codd's model and trying to marry a user-friendly visual front end to the theory behind it. In 2010, so we're still on the decision model was adopted by a leading financial institution even without commercially available software. And that's really important to understand the value of a model, that clients are interested in adopting something even before there is technology to take it the rest of the way. The year of 2012 saw the spread of decision modeling and enterprise software from Sapiens Decision. And this past year, we now have a new standard from the OMG called the Decision Model and Notation. And our decision model was part of the inspiration for this new standard, and it validates decision modeling as a discipline and opens up a whole new marketplace for software. And the third part is the part that's most relevant to this webinar. In 2013, KPI joined the IBM research team to do the same kinds of things with events in developing the event model and reveal it to the public now in 2014. So what we kind of did, that IBM was very well on their way when we joined them, but we were trying to marry a diagram notation with appropriate theory and principles, as well as keep it business-friendly and technology independent at the same time. So these three different models are interesting because they model three different assets: the relational model, model data, the decision model, and event model, model logic, but it's different kind of logic, so I'm going to point that out to you. For now, just consider that the logic in a decision model represents the correlation of fact-based conditions to fact-based decisions. An example of a decision model is a conclusion as to whether a student qualifies for financial aid based on the raw data or the facts that are provided in their financial aid application. And that is, raw input data is evaluated with logic to come up with an eligibility decision about that student. On the other hand, the logic in the event model is a little different. It represents the correlation of event-based conditions and context, which I'll talk about, to corresponding event-based conclusions. So an example from recent events would be detecting various raw events, such as when a communication system on an airplane is turned off and then a second one is turned off and the aircraft changes course. Coming to a conclusion from these raw events that there's something there's something larger, there's an event larger that is happening than simply those individual raw events. And that is what the event model is all about: evaluating input raw events to start out with, moving them through different sets of logic, and concluding that a much bigger event is painted when you look at all of those raw events together. So we have 5 lessons that we learned from both the relational model and the decision model, and think about them, applying them to the idea of an event model and potentially some other models down the line in time. So first, a predefined technology-independent model is a good thing. The idea of having a vision first and technology afterwards is a very good way to go. Second, a universal business-friendly structure is also good to separate the business representation from the technology representation. And third, the underlying principles are good if they can prescribe structure, technology independence, and optimum integrity within that structure, whatever that model is. And fourth, a solid theoretical foundation of normalization and additional principles is also good. It reduces each of the assets in the model to its minimal presentation, and that saves overhead and maintenance and saves the opportunity, or reduces the opportunity of errors. And finally, fifth, the holy grail is model-driven code generation. That's not only good, but it's outstanding. And what the idea would be in all of these models is to generate code directly from the model. That means that non-technical people can create models and maybe execute them for testing or validation and for potential deployment. And so while each of these models is different from each other, these are the 5 characteristics that are in common and should serve us well in future models. So knowing that history, let's explore the next dimension, which is what we're all about, is the event model. So I will cover the specific differences between the decision model and the event model because I know these are very important. Some of you have indicated at registration that this is a topic of interest for you. So I will go summarize these at the end of the presentation. But let me first point out that this webinar is about the event model as a logical model for defining event logic. That is similar to how the decision model is a logical model for defining decision logic. So this webinar today does not address technology that is needed to deploy event models into executable code, just as the decision model by itself does not include or imply certain technology tasks or inventions that are needed to deploy decision models. So what you will see today is a model for event logic that should be easier to create and understand than what your organizations are doing today. So here is yet another timeline, but this is an interesting one. The IBM research team is under the direction of Dr. Ofer Etzion, and this is his timeline. he's a very important person in the event world and certainly a great leader in the event model. So most important on this timeline, I have identified or highlighted that in 2010, he received the IBM's highest award for groundbreaking research on event processing, which established IBM as a leader in the new field. And he also published an authoritative text on event processing also around 2010. And I just want to mention that the IBM team consisted of 3 other people. We had Fabiana Fournier and Sarit Akushin, both in Israel, and Jeff Atkins from the United States. And then Larry Goldberg and myself were the remainder of the team. So let's get started on what are events, because what I don't know is how much information you folks know about events. A little bit, some of you have some experience and some of you don't. So what are events anyway? So we say they are important things. Events are important because they represent today the harnessing of happenings and related information that are shared through the internet or devices or other means for the purpose of deriving either a current larger event or a past one or even future happenings that a company, an organization, or even a government needs to react to. So these happenings may be good things like marketing trends. They could be critical things such as medical emergencies. They could be dangerous things such as suspicious activity on a bank account or something happening to an airplane, for example. So these are happenings. These are things that are happening that we want to harness. We can detect them, and we want to do something when we do detect them. So some of you in the questions that we asked, you wanted an explanation of how the event model, the decision model, and BPM, business process modeling, fit together. And this is perfect because here's a diagram developed by Dr. Ophir Etienne, which explains how they fit together as the 4 Ds. These are detect, derive, decide, and do. So it starts with detecting the happenings, like the raw happenings, like just a single bank activity. Or it can be signals from a medical device or signals from an airplane, for instance. And so once we apply logic to these detected raw events, it brings us to the second D for derive, a virtual event, if you will. A virtual event is a happening of greater magnitude and importance than simply the individual happenings by themselves in a vacuum. So the ultimate virtual event in the event model is called a situation. And so the output of a total event model is that thing called a situation. We'll take a look at some examples. Once we derive a situation starting with the raw input and then derived events, we move to the third D, which is to decide what to do about that situation. And so, the detection of the raw events as input and using logic to conclude derived events is what happens in the event model. Deciding what to do about that situation that you have now derived happens in the decision model. And then the reaction of what to do once you make that decision may happen in a process model or a task, depending upon the context of your situation. So it's also important that the event model adhere to the 4 items on this page, as these have proven extremely valuable. So before we look at examples, we'll take a look at these 4 things. The first is a rigorous, verifiable structure so that there is a universal representation and that it is as simple as possible without losing the essence of event derivation. So we do have to deal with some complexity in the event model that we don't have to deal with in the decision model, but our idea was to make it as simple as possible without losing anything. The second is that the detailed logic be represented in a collection of tables, much like relational tables and rule family tables. There are other representations that may work, but we began with tables. The third is that it be free of implementation knowledge so that it is understandable by non-technical audiences and also unconstrained by technology. And the fourth is of the Holy Grail, the automatic translation to code in specific or general languages. And these minimize the opportunity for error and deliver optimum productivity if you can actually deliver that fourth part. So we need to define a few things just before we take a look at how to build an event model. An event we are defining is an occurrence of something that has happened that is of interest to a business and is published, which means that we can detect it. And we detect it and publish it because it may require a reaction on the part of the business. So a raw event is simply the raw output of a producer. An example of a raw event here is a simple cash deposit into a bank account, and its producer may be the banking transaction system that detects this raw event. Raw events in the event model are similar to raw data in the decision model. And now a derived event, as I've already stated, is the output or conclusion of event logic. An example of a derived event shown here is a large cash deposit that has been made into a bank account. The event logic in this case probably contains the criteria for qualifying a specific cash deposit as being a large one. So we're making a judgment, we're coming to a conclusion. So a derived event in the event model is similar to the inferred knowledge or interim conclusions that you're familiar with in the decision model. Now a situation, as I said, is the final conclusion from an entire event model, and it has at least one consumer who is interested in it. This means that the situation is published to the consumer who cares about it. A situation in an event model then is very similar, plays the same role as the conclusion in a whole decision model, because both are the final result of a model of logic and both are published external to the model. A decision model publishes its conclusion usually to a subsequent process task, while an event model publishes its situation to its consumer. So already you're starting to see a little bit of difference in the context of how and where they execute. So suppose we want to derive a situation where we believe an account is suspicious. We start with a raw event, again, similar to raw data in the decision model, and we create logic that detects them. In this example on this page, we detect cash deposits. Those are the raw events. From these raw events, we want to derive more knowledge about them, specifically whether what the statement says here, whether we have at least 3 large cash deposits, and specifically if these have happened within the past 15 days. This is similar to how in the decision model we come up with interim conclusions from raw data and we keep on going. If we finally derive in the event world that these things have happened, that indeed there have been at least 3 large cash deposits and within the last 15 days, then we can conclude that this account is suspicious. So next we decide what to do about it, and we do that with a decision model. And on this page, our decision models, maybe we have 2. We decide on an assigned risk score, and then we take an action. And the process continues potentially by doing that action. So just as data existed before the relational model and business rules and logic existed before the decision model, events have certainly existed before the event model. So what do you folks do with events today? What's happening out there? One option is to use process modeling. That's what we did with data, and that's what we did with business rules before we had a model just for data and for business rules and logic. But process modeling is not a desirable solution for the event model any more than it was for the decision model for a lot of these kinds of reasons. Not all events fit within a well-defined process. That usually decision models do fit within a process, but events don't necessarily. They're sort of random, or you're trolling for things happening out there. Event logic in a process model is hidden and buried. Event logic is difficult to define in process model notation because it's really not the right notation. And event logic is also cumbersome to change. Another option is to represent event logic directly in program code. So we did that in the decision model world before the decision model. Lots of folks went directly to their business rule engine code, and then we lost them, right? So the same kinds of things happen when we do that with events. So program code is not the ideal solution. Program code is certainly not understandable by business people who are our primary or one of our primary audiences. The logic, of course, gets lost in the code. We've seen that in the business rule space. Program code is difficult to define and it's cumbersome to change, and especially if you lose a link from what the business person wanted and what the code actually does. And typically later, changes get made directly to the code, and you've lost all record of why you were doing or what you were doing before you created the code. So we lose the business folks with this approach. But let's take a look at when we have an event model, we have a diagram. And it has business understandable labels and a structure and a rigor. So we will look at it in more detail, but for now, some of you wanted to understand the interest between events and impact as well as event ontologies and hierarchies. So perhaps when we look at the TEM diagram in detail, you'll kind of sort of see at least a hierarchy and an arrangement of smaller events that build up into larger events. But some of the benefits, if you're familiar with the decision model, you may recognize some of these. A simple diagram designed specifically for event logic. There's no program code required to understand the event model. It utilizes a business-oriented glossary that the business people create parts of it and they understand what they're talking about. It has no technical terms or artifacts. It is independent of technology, which means it can be implemented in multiple technologies. It's supported by integrity principles, much like the decision model and the relational model. And it's fully automatable because the principles of the event model are richer than the principles of the decision model. Our decision model has 3 sets of principles, as you know, but the event model has many more principles, some of which are geared towards the technical audience. So it's a little bit more, more fully developed in terms of getting you to automation. So the event model also has more pieces than the relational model or the decision model. And for starters, it has more concepts. And these include consumers, you've seen already, producers, data, events, etc. And there's also a glossary and the principles that provide rigor to it. But I'm only going to focus on 2 parts, 2 important parts, the diagram and the event derivation table, which I tend to call a TEM logic table. Okay, so let's build a TEM logic table from this statement. You've seen this statement before. It says a suspicious account is derived whenever there are at least 3 large cash deposits followed by transfers abroad in the last 15 days. So how are we going to do this? First, we have to understand timing in the event model. One of the complexities of event logic compared to the logic and decision models is the consideration of time. Event logic must most often involve detection of events where time is part of the equation. That's not normally the case when you're processing in a decision model an application for financial aid or a mortgage application or eligibility for a particular mortgage program. We don't have a whole lot of time conditions. So this page shows 3 kinds of time-related considerations that we need to understand. The first example requires logic that evaluates the actual time that an event occurs. The example is that a delivery should be confirmed by the promised deadline. If it is not, then I suppose the related conclusion is that the delivery is running late. The second example requires that you compare the order or the sequence in time of events that occur. So this example seeks a first bidder. So we expect multiple bidders. We want the first bidder who comes through with the highest bid. So we have the notion of first among multiples. And the third example requires logic that seeks only event occurrences within a defined time window. In this example, it will require logic that understands when rush hour is, detects events that are occurring with it, because those are the ones we're interested in, and also ignores events that happen outside of it. So we have a lot of timing things that we have to deal with, even probably in the simplest event model. So therefore, a TEM table has 2 parts. It has a context part and a conditions part. So the context part is what I was just explaining. Part of it is time, and part of it is partitioning. So what does this mean? Because the input to an event table is a collection of event occurrences, we need context to define the various ways we're going to group these occurrences into partitions so that we can use event logic that can operate on whole partitions. We want to do things like count. We want to do things like compare different event types to each other that occur within that partition. And right now, the event model defines 2 kinds of context. The first is the ability to group event occurrences based on a value, such as grouping all cash deposits by an account ID. The second is the ability to group together occurrences based on time, such as between a start time and an end time, or a specific time frame that uses other keywords to explain the time frame. So in this example, we have 2 contexts in this statement. We have a grouping of occurrences by account ID because we want all the activity in one account, and we also have a timestamp selection, or in the last 15 days. So we need to break all those input occurrences into groups using these 2 pieces of context. So you have 2 event logic tables here, and let me just take a look. You can see where the context is. The context are the 4 columns that are circled. So remember I said an event logic table has two parts. It has context and conditions. The first four columns are the context. The first thing to know, though, is the name of the derived event, because remember each of these tables derives a new event from other events. It's simply the name of the table. So in other words, the table on the top, if the logic in it is true, it has detected frequent large cache deposits. There's no need to have a separate conclusion column because all you're doing is detecting an event. You're not doing all the kinds of things that the decision model does. So we can just simply make it the name, and we know that every single row in here leads to this particular event type. And in the TEM table, there are also, four different columns for the different kinds of context. So we have these two. They are pretty much the same. So these two tables, the context does always execute these tables when there is an input event that sends something to it, and we want to group that input by account ID, and we really only care about the last 15 days. So TEM is more complicated because it needs to evaluate input over time, not just static input like a mortgage application or a healthcare claim. It is detecting various happenings over time and doing so within a grouping so it can come up with a conclusion. So the other columns are for conditions, the other four. So let's take a look at that. So we have event logic defined as conditions on single events and on grouped events leading to a conclusion. So as far as conditions are concerned, there are three types of conditions because the event model logic is a little bit more complex than decision model logic. So I will explain the three first, and then we'll look at this page and look at those particular examples. So without going into syntax, there is a condition type called filter on event, which simply evaluates each individual event occurrence within the context where the context is defined in the same row. And then we have a second condition type, which is called pattern, and which evaluates multiples of event instances. And these can be multiple event instances of the same type of event or instances of two different kinds of events. And I'll show you an example of that. And the third condition type is called filter on pattern, which evaluates relationships among the multiples. So what you're seeing is we have very simple conditions that are probably quite similar to the decision model ones. Then we have more grouping, group-related or multiple instance logic, and then we have even more complicated logic when we have different groups of conclusions and different groups of different kinds of event types. So let's take a look at the top. Event logic table contains a condition type called a pattern, and it executes by definition on multiple instances. In this case, look what it does. All it does is count. It counts the number of multiple instances of one event type called large cache deposit, and of course it does this within the context, which is for the same account ID within the last 15 days. And also you can note, by the way, that large cache deposit is underlined, and those of you who are familiar with the decision model know that this means that that particular event in there is actually the conclusion of another event table. That's how the tables connect together. The bottom event logic table also contains a condition type of pattern, but this one's a little bit different. It executes against multiple instances, but this time these are of two different event types. One is large cache deposits, and one is transaction abroad. So now we're comparing two different event type instances with each other. And again, within the context, which is within the last 15 days for the same account ID. Notice here also that frequent cache deposits is underlined because it actually is the derived event that comes from the event table of others. And so this is basically the structure of the event model tables. We have four columns for context, which allows us to take all the input occurrences and group them. And then the conditions operate on the groups. And some of the conditions operate on each of the instances. Some, and the other two operate on groups of instances, depending on what the logic is itself. And some of you have indicated an interest in normalization in this model in your registration questions. So I'm not going to go into that, but suffice it to say that the logic inside these event tables adheres to principles of the event model to make sure that there are no unnecessary redundancies and that they are normalized. Okay, so here we define the event model diagram as a model showing the structure of the logic behind the event derivation such that this model or diagram has its own structure. It's not the same as a process model. It's not the same as an object model or data model. It's not the same as a decision model. It's got its own syntax and its own look and feel to it. So it is a representation unique to event logic, and it reveals the structure of the logic but not its details, because the details are in the tables. Just like with the decision model, you have the decision model diagram, and the details of the logic are in the rule family tables. So we have time to draw an event model diagram. Let's go back. Okay. So very much like the decision model, we start in the event model with where we're going, where our goal is. So we start with the situation we want to derive. Just like with the decision model, we start with the conclusion that our decision model is supposed to give us. So in this particular event model, we have a situation. We want to derive the situation of a suspicious account, and we add it to our diagram as a rectangle with a flag in it, and we connect it to the consumer who cares about it. So in the event model, you don't have the octagon like we have in the decision model. The decision model has the octagon because that's how we link it to process models, because all decision models pretty much are linked to process models. Event models aren't necessarily linked to process models. And so we don't have that particular icon in here, but we do have a consumer who's supposed to receive the output of the model. And so in this case, the situation we want is a suspicious account, and when it is derived, we provide it to its consumer, who happens to be the compliance officer, so if the consumer has an icon of looking like a person or a role. So next we decide what kinds of events lead to our situation, what kinds of things lead directly to a suspicious account. And here apparently we have 3 of them. Someone says if we have frequent large cash deposits, that's important. Frequent cash deposits followed by transfers abroad, so I guess they don't even have to be large cash deposits, and also a lack of account activity. But none of these are raw data, right? So since none of these are raw data, they go under the suspicious account situation, and they are individual conditions, they're conditions that we're going to look at that are conclusions from another table. So if you're familiar with the decision model, this should feel comfortable to you. You'll see some red lines behind those. Those red lines tell you that there's context you're not seeing. Remember, the context is how we're grouping the input events by, let's say, by account ID or by time. There is context, and if you want to see that, I'll show you a little bit more on that. But right now, we just care about the conditions. So now for each of those derived events, we create a branch in the model like we do in the decision model, for which they are the conclusion, which would be a derived event. And they have their own logic structure. So here we have 3 branches, right? One is frequent large cash deposits. That's its derived event. One is frequent cash deposits followed by transfers abroad. That's its derived event. And then we have lack of account activity. That's another derived event. And we add to each branch the input events that lead to them. And so if you look at the leftmost branch, the frequent large cash deposit, the input is simply an event type of large cash deposit. So we can guess that all this logic table does is just count how many happen within the context. And if it happens to hit the number we're looking for, then we consider it to be frequent. In the middle branch, which is the frequent cash deposits followed by transfers abroad, the input is an event type of cash deposit followed by transfer abroad. So we can guess we're just going to count when these 2 event types happen within this context. And the rightmost is a little bit different. The lack of account activity has as input cash deposits that are absent and transfer abroad, which is absent. And these are simply raw events. These are not derived from logics. And so we have a little icon there known as a lightning bolt. So there are no derived events below this branch. This branch is complete, just like you would find in a decision model. So when you reach a point at which all events are input are raw, then you need to connect the producer to those events. Where are those raw events coming from? And so we have our nice little banking transaction producer on the bottom, but we can't connect it to the other 2 branches because we haven't reached a level at which we have only raw events coming in. So finally, we keep repeating the analysis on all of our branches, which is exactly what we all do with our decision models. And so we bring these all the way down. On the left-hand side, we have as input the output of the bottommost event table is set with a large cash deposit, which has as input a cash deposit and some information to compare it to numbers to see if we consider it to be large or not. For the middle branch, the event type of cash deposit followed by transfer abroad, it has two raw events, cash deposit and transfer abroad. So we have now hit the bottom because both of these branches have either raw events or raw data coming into them. Then we just simply connect them to the producer, and so we have finished our top-down event model. So you can see the red lines on some of these event logic structures, which tell you that there's context behind them. But if I'm going to show you, here's an example where if we want to see a little bit more about the context, we see that there is a clock, which tells us that the right-hand branch has a context that is time constrained, and it also has the hierarchical figure there that tells you that it's being grouped by something, and it tells you it's being grouped by account ID. So if you look at that, you know a lot about the logic that's in that table, even without seeing the table. And so just like with the decision model, now we just simply create our event logic tables behind each of these shapes, and then we'd be finished. So on this page, there's an event logic table for large cash deposit. We don't need to go through what the logic looks like, but this one has a very simple condition on each individual event to determine if that cash deposit is large or not. And then on the next page, we have like several pages here that go through the event logic tables behind each of these structures. We don't have to go through all of them. In this particular example, let's look at this table a little bit. It is the event logic table to determine if a cash deposit is followed by a transfer abroad. It groups the input events by account ID. We see account ID same. It selects for us only those events that have occurred within the time frame of a cash deposit and 3 days afterwards. And then here we have two kinds of conditions. We have a pattern condition and we have a filter on the pattern because we're doing a little bit more complicated logic. But then the result of this, if this actually turns out to be true, that within this context, these conditions are true, then what we can conclude is that we have a cash deposit followed by a transfer abroad, and that they were two related events. And then, of course, here's our frequent large cash deposits. Looks like we're counting the large cash deposits until we get greater than 3, and we're checking every 10 days to make them frequent. And now we have another one for the frequent cash deposits followed by transfers abroad. And you keep on going through all of these. This one's an interesting one. I just want to point this out. This page shows the event logic table for a lack of account activity. So apparently it is testing for the absence or presence of raw events. It specifically evaluates whether a cash deposit is absent and a transfer abroad is also absent, then the conclusion is a lack of account activity. So just as you do in the decision model, the conditions in the row are ANDed together. So this means you have to have both no cash deposits and no transfers abroad in your context window to say we have a lack of account activity. This one is even more interesting, or just a little bit insightful. It's the event logic table for the entire situation. So it's the table that sits behind the very top structure. And it's what you wanted to build your event model to do in the first place. And there are 3 rows in this table. So apparently, if you look at those 3 rows, we will derive that an account is suspicious if frequent large cash deposits are detected, or if frequent cash deposits followed by transfers abroad are detected, or a lack of account activity is detected. So if all of those had to be true for our account to be suspicious, they would have all been in the same row connected with an AND. But what this logic table tells us is only one of those has to be true for us to be suspicious of this account. And so that's a lot like the decision model, right? So we have our ANDs and our ORs using our principles. And of course, so what we've presented here is there's the structural model, and then there are the individual tables. And you can develop them iteratively if you like. We have not addressed the technology needed to actually make these events, capture these events where they're happening, and send them over to the processor that's going to process the event model. So for those of you who wanted to know some of the differences between the decision model and the event model, this is something that the IBM team and we put together, so I don't need to go through all of them, but I will go through a few of them. The first category of differences is the foundation of each model. The decision model's foundation is decision logic, which comes to a conclusion based on facts, of data. It only senses data. It doesn't sense events. The event model's foundation is event-driven logic, which reaches a situation, a bigger event is happening out there based on the detection of related events and the data associated with those events. So when you get a cash deposit, that's an event, but it has with it the amount of the deposit. So my event model will have data with the events that are happening. It may also go out to a database and compare that to something. So how are they invoked? Here's what's interesting. The decision models are usually invoked by a process task. I think most of you know that, right? But event models are invoked whenever events are produced that are relevant to the situation that we're looking at. So the input for the decision models is usually a predefined set of fact types or data, such as those appearing on an input form. But to the contrary, input to an event model, while also we predefine it, you can see by the model structure, we tell it what the conditions are that we're looking at. These are really events and event-related pieces of data, and there can be multiple types of events, and there can be more than one source. So you've got lots more stuff coming into an event model to make heads or tails of. Decision models execute within a process task, but event models execute continuously, always out there looking for detecting any of these events. And then we have a glossary in those cases. The decision model only has fact types in it because that's what business people use for their conditions. But the event models have other types of concepts like producers and consumers and other types of things. So you have a little bit more sophistication there. So what was the goal of the event model, the vision? We wanted to move the current day event paradigm, we, with the IBM team in particular, out of governing through program code, relying almost totally on technical people to do that. Just that's how we used to do business rules and logic. Also, into governance by knowledge workers or compliance people or government people who work through event models, and so that they can go and make changes to the event model, not directly to program code. And they can understand the event models, they can compare them, they can validate them, and potentially even test them themselves. So the final agenda item is a short one. It is delivering the next dimension, which is the event model. What are the benefits and what is needed to take it to the next step so it becomes available? So the benefits, I organized these together. I think the benefits are that if you're using event models over other techniques, it enables business governance over your event detection from raw events to your situation to how the company or organization should react. It delivers a universal event representation that can be used by both business and IT. There's no Java there. There's no data models and object models right there. It's just simply what you looked at, using business people's words. It defines a technology-independent solution, so you should be able to deploy it to multiple technologies. And we'd like to capitalize on the automatic generation of code, which, of course, would make it even more useful. So those are the benefits that we see coming from people who use or deploy the event model. So what do you want to do with the event model? For those of you who want more information on the event model, I'm sorry to say there is not much reference material for public consumption at this time. However, there are two interesting items out there, and they are both related to IBM. There is a video that IBM has created, and if you want to look at the video, you can simply Google YouTube the event model. There's also a conference tutorial given last year by Dr. Ofer Essian, and you can Google SlideShare the event model, and you can find those materials, or you can download this presentation and use these links. I will mention right now, because this is the exciting part, the researchers are looking for the means to take the event model to the next step, which is where we were in 2008, taking the decision model to the next step. And that is to work with real organizations, either test it, take some of logic and put it into these templates of decision model, event model diagrams and tables, and then eventually to develop software to support it. That's exactly the history that the decision model had. And so it's reasonable to think that that is the future. And if you notice how the models between the relational model, the decision model, and the event model, things are happening a little bit faster now. It doesn't take us 20 years to understand the formal model anymore. So if this is of interest to your organization, if you want to share in the pioneering and what may be extremely significant advances, please contact Michael Gross at KPI. His email address and phone number is here, and he will coordinate with you the paperwork that's needed and to coordinate it with the right participating people. And two things I'll close with. I want to close with a very special thank you to the IBM team. Working with them was one of the highlights of my career. This has been very rewarding for me, so I think that this was really an excellent project with a lot of promise. And then second of all, I want to thank all of you for listening to something that's new on the horizon. I truly hope you found it to be innovating and thought-provoking. And I will now turn it back over to Jeremy.
Thank you, Barbara. Well, we hope you were stimulated by today's webinar, which is part of KPI's Innovation Series. In a moment, we'll get a chance. We'll try to answer a couple of questions. Several have come in both during the webinar and before the webinar. But if we don't have a chance to get to your questions, we have got them recorded and logged, and we'll follow up with you after the webinar. Please watch your inbox tomorrow for a follow-up email from us. In addition to a link through which you can provide us feedback on today's webinar, the email will contain a certificate which you may use to claim continuing education credits with your various certification administrators. For more information about KPI's upcoming webinars and events and to download our free educational materials, please visit the KPI website, www.kpiusa.com. That's kpiusa.com. For those of you interested in training on the decision model, we offer a monthly online live instructor-led class called Decision Modeling Essentials. This class is held on the third Tuesday through Thursday of each month. It runs for 3 hours, each day for 3 days. Information and registration is on our website. Perhaps the best way to plug into the decision modeling community is to become a member of the Decision Model group on LinkedIn. To find us, go to LinkedIn and search the Decision Model. All right, so Barb, we have a couple of minutes before folks have to get back to their day. Let's see, you've answered a couple of the questions that had come in during the course of your presentation. Is there any more as far as a research project where TEM goes from here that you'd like to highlight?
Well, I think the most important thing to know is that the event model is being tested in some academic institutions, and so there's been some practice with it and developing some models using the syntax and using the templates. But of course, the next thing is to work with clients. So real organizations have real events that they want to test in it, because we also want to make sure that we have all the syntaxes and we can handle everything that an event model might need to handle. Again, this is only version 1 or release 1. There are future enhancements potentially for the model, but we just wanted to, some of the researchers want to see how robust is it at this point in time? Is it ready for real time?
Terrific, thanks so much. And might TEM be combined with TDM, that's the event model combined with the decision model, to deliver one integrated model?
That's a really excellent question, because we did play with that question over and over again over the months. And so here's the point. There are similarities between the two because they both deal with logic and they both come to conclusions, whether you call it a situation or a conclusion. But there are more differences than there are similarities. So you've seen that, the event model has context and deals with multiple occurrences of events happening randomly. All the differences in that table really spell out that they are different. But you can certainly have an application or an area of the business where you need both, as you saw with the 4 Gs. So I see right now that what will happen, I think, is that the event model will get richer and richer and richer. The decision model will get richer and richer too, but the decision model, its scope is pretty much well defined. It's feeding in raw data and coming up with a data conclusion. That's simpler, less complicated than the event world. So I believe that they will stay separate.
Okay, so no, kind of separate for now.
No.
All right. So let's see. It looks like we have time for one more, and I am curious about this. Will there be the event model book?
Well, the answer to that is I don't know. There are no plans for one at this time.
Okay, fair enough.
There should be, but I'm not sure I should be a writer. But there should be one. I think it would be very helpful.
To those of you authors out there, take note. All right, there's a lot of great questions coming in, and I'm sorry that we don't have time to answer them all, but please be assured these are being categorized, recorded, and we will make our very best effort to get back to each and every one of you. And that's all the time we have for today. So on behalf of Barbara Von Halle and all of us here at Knowledge Partners International, we've enjoyed being with you. Thanks for joining us, and this concludes our broadcast.